polarization is the direction of E field. Direction of E field. So based on the direction of E field, you can classify two categories. One is linear polarization, where you see that the electric field is in the X direction. So all these red vectors are going in the X direction. So this is X, this is Y, X cross Y is Z. So that is Z. So the whole wave is propagating along Z. As you can see, it's propagating along the Z direction. Since the electric field is in the X direction, you called it X polarized wave. Similarly, you can have an antenna which is circularly polarized. So here, the electric field keeps rotating in circle. So certain applications, you might want to have simply linear polarization. For some applications, you might want to have circular polarization. For example, especially satellite applications, you would have circular polarizations. The reason being the atmosphere, right? You have this Earth here. This is Earth. Then outside Earth, fortunately, we have this nice atmosphere. This is the atmosphere and the satellite out here. So this guy, as it sends the signal, the Earth's atmosphere behaves differently for the two different polarizations, linear, vertical and horizontal polarizations. So in order to not miss out the signal anyway, what engineers smartly did was, since you're going to have loss in one of the directions, one of the polarizations anyway, let the satellite transmit circular polarization so that even if there is loss, you can recover back from the other polarization, because you don't know ahead which component is lost, because the satellite can be oriented in any way, it can be in any part of the Earth, so on and so forth. So if one is lost, the other term can always come in. Yeah. So it is effective to use circular polarization then. So the question then is, the antenna on the mobile phone, should it be linearly polarized or should it be have dual polarization? Should it be able to receive in both polarizations? The answer is it should be able to receive in both polarization. Yeah. So that's why if you see the base station antennas these days, you will see that all these have polarizations, antenna elements like this. Of course, you can't see it because they enclosed it with that. If you go and break open, tear down a base station antenna, you will see antenna elements like this in a crisscrossed, zigzag manner, where you're having this polarization as well as this polarization, so that no matter how you're orienting the phone, you're still able to receive some signal or the other. Why is it important to know the polarization of the antenna? When the transmits a certain polarization, the receive should also be aligned. Yeah, it's like talking the same language. If the receiver is also the same polarization as the transmit, then they are like talking the same language, so the information get passed through, so you are able to receive the signal. If you transmit in this case vertical polarization, this is vertical, this is also vertical, but this is vertical, but if your receiver is horizontal, then you don't receive anything. So there can be a polarization mismatch. There is no communication. So that's why in cell phone applications, you must have both those polarization, dual polarized. This is called as copole. Transmit V, receive V. Transmit V, receive H is called as crosspole.